holidays? The sport?
Huh?
Did you get that for the holidays?
Yes. Do you know Mrs. Schomer in technology? She gave it to me.
Hey.
And her and Mr. Landeris, they both kind of gave it to me. Isn't that nice?
It is.
And so a kid helped me get it all set up. And now my only challenge is I have to remember every night to turn it off. So we don't burn down the school. All right, so here we go. But it does make it smell better in here, doesn't it?
It does.
All right, so here we go. This is our situation. And you know trigonometry is triangle measurement, so we're always going to make triangles. And in case you've forgotten, the triangle you make is always going to be part of the butterfly bow tie. When you draw your picture, it has to be one of those 4 triangles. Got it? Don't do something like this, kids. That's not right. You won't get the right answer. Don't do that. Make sure it's part of the butterfly bow tie.
Butterfly bow tie.
Yep. Now, in problem B, I am told this is the point 1, -2. That means I'm going over 1, here's the origin, I'm going over 1 and down 2. So there are the sides of my triangle. How will I find the missing side, the hypotenuse? I'll do the Pythagorean theorem. Now remember, it's a squared plus b squared equals c squared. When you start squaring, everything's going to be positive. Do not put any negatives in the Pythagorean theorem, okay? A squared plus b squared equals c squared. So 1 squared plus 2 squared equals c squared. So c squared equals 5, and this is the square root of 5. X and y, those can be negative. This number will always, always, always be positive. Always. Now there's our picture, and from that picture we're going to find the sine, the cosine, and the tangent. And the cosecant, the secant, and the cotangent. Now Mrs. Ford always puts them in that order because they're lined up with their reciprocal. So once I find this one, all I have to do is flip it over and I'll have that one. Okay, so speaking of that, what is the sign? Exactly. Remember, the angle we're looking at is at the origin. Always, always, always. In your butterfly bow tie, your angle is always going to be right here. So you're going to gauge opposite, adjacent, and hypotenuse off that angle. So Gabby said -2 over root 5, which is -2 root 5 over 5. Which means the cosecant is root 5 over -2. Everybody okay with that? We've done that before. All right, what's my cosine? Cosine now, cosine. 1 over root 5, which is root 5 over 5. Yep, very good. Which means the secant is root 5 over 1, or if you just want to write plain root 5, you can. And then what about my tangent? What's my tangent? -2 over 1, or just -2, which means the cotangent is -1 over 2. Now, does anybody have a question about that? All right, let's look at the next one, and I'm not going to walk you through every step on the next one, but I will help you get it drawn. This time we have this part of the butterfly bow tie. And this point is -1, 3. So left 1, up 3. Now I'm going to stop there, and I want you to look at what the picture is in the book, and I want you to make sure you understand what I'm doing there. I know this vector goes on farther, but I don't care about that. I the triangle, so I'm gonna come over 1 and up 3, because that's the point they gave me. Got it? What's the next step? Think about what we did over here. What's the next step? Gotta find the hypotenuse. And how am I gonna find the hypotenuse? A squared plus b squared equals c squared. So figure that out all by yourselves. Don't put any negatives in the Pythagorean theorem, ever, ever. It's always gonna be all positive. So you have 1 squared is 1, 3 squared is 9. So it'd be 1 and 9, Chris? What's 1 and 9? 10? So it'd be the square root of 10. It's not 1 and 3, it is 1 squared and 3 squared. Everybody got it? Kian, you with me? All right. So now we're going to fill in all those blanks again. So I'm not going to rewrite it all. Oh, you have to, unfortunately. Let's see if we can figure out what our new answers are. What's our sign? 3 over root 10.
3 root 10 over 2.
Which is 3 root 10 over 10. You are perfect. And then the cosecant is root 10 over 3. What's our cosine? Negative 1 over root 10. Everybody understand why it's negative now? Because that negative 1 over root 10, or negative root 10 over 10, which means my secant is negative root 10 over 1.
Wait, why? The negative one stay with what?
The negative can go anywhere. When you write a fraction, like 2/3, this is negative 2/3, this is negative 2/3, and this is negative 2/3. So you can put the negative on the top, the bottom, or the middle, it doesn't matter, just have a negative in there. If it's easier for you to keep it with the 1, keep it with the 1. What's my tangent?
Negative 3.
It's 3 over negative 1, which if you want to write that as negative 3, that's absolutely fine. I don't have a problem with 3 over negative 1, but it is negative 3. And that means my cotangent then is negative 1 over 3. All right, I want you to do D. I want you to do D on your own. See if you can make that triangle. For D, do you know what you're doing with your triangle now? It's up here like this, over 4, up 5. Robbie?
I did it.
You already got it done? So it's in quadrant 1, which means, will I have any negatives? No. Everything will be positive. So what are you working on now? What are you doing now? Finding the hypotenuse? Jake, you got this done already? No, let's do it then. What did you get for your hypotenuse? Root 41. And you got root 41 because you have 16 plus 25. What did you fill in for your sign? Okay, we're doing sine now. So for sine, we want opposite, right? Remember, this is our angle, so we want opposite. So 5 over root 41, yep, which is 5 root 41 over 41. And this would be root 41 over 5. Now, when you plot the point 4, 5, Trey and everybody else, it matters where you put the 4 and the 5. This is your X. So we're going over 4, up 5. So the 4 and the 5 have to be in those spots. You don't get to mix them up. All right, so what's my cosine? That one's 4 over root 41, or 4 root 41 over 41. And then what's my tangent? 5 over 4. So the cotangent is 4 over 5. Now I want you to look at problems 2A and B. Yeah, 2A and B. We'll start with those. They, believe it or not, are exactly the same problem. The only difference is, instead of drawing a picture for you and plotting the point, I just gave you the point. So for problem A, 2A, you are going to plot 2, -2. So where's 2, -2? 2, -2. So you're going to have this triangle drawn. Does that make sense to everybody? Plot the point, right and down. So that's a 2 and that's a -2. Now what about for question B? What's that one going to look like? Left one up 4. So that triangle's over here. Left one up 4.
Bless you.
It is exactly the same problem now. So I'm going to leave you to do these 2, and then when you get them all done, when somebody gets this one done, I want you to come up with the answers up here, and we'll do the same thing with this one. All right, so this goes over here, and then I'll write down here, I'll put the other one. So when you got one of these sets done, come up and put them up there. Everybody else work, and let's check these answers. Yes, I got them out. They were my Christmas present to myself.
Go Marley.
Now, I want you guys to be the graders. How did the girls do? Thank you, girls, for doing this, by the way. Anybody have any thoughts about this? Anybody not match? Surprised nobody's saying something. What?
-4 on the sign.
On the sign.
No, it's because it was
Should Marley, the question is, should this be negative?
No.
The sign is 4 over root 17 for sure, but that one shouldn't be negative. And you didn't make that one negative, so maybe it's just an accident. I don't know. Yep. There's something else that has me just a little bit, not a huge deal, but worth a little bit off. Tell me about the square root of 8. Ah, the square root of 8. This hasn't happened to us in any of our other examples. Like root 17, this is root 17. That does not simplify at all. But what about the square root of 8? That's 2 root 2. So, if we do that, yeah, these are right. I just don't have room to redo them, so I'm going to erase them here. If that's 2 root 2, then my sign would be negative 2 over 2 root 2. And see these two, they will actually cancel. So we have negative 1 over root 2, which is root 2, negative root 2 over 2. And then this one would be negative root 2 over 1. Okay? Cosine, going to be exactly the same thing, only it's positive. So 2 over 2 root 2, those cancel. 1 over root 2, root 2 over 2. So Gabby had exactly the correct answers. She just didn't simplify her root 8, which apparently none of you did either. And we want to make sure we simplify any radicals that simplify. Are we good on that? No question about any of them now? Well, very nicely done, girls, and thank you to everybody out there who worked on it. C is tricky. C and D are new stuff, and they're tricky. Tell me what's different about problem C. Well, yes, when you draw a picture of problem C, where is the point? If I said plot 0, negative 2, where would you plot it? Where is the point 0, negative 2? It's right here, isn't it? Now, Mrs. Ford made a big, huge deal about the fact that when you draw a triangle, it must be one of these. Can't do it. Can't do it. Robbie?
I was gonna say, couldn't you do the Pythagorean theorem, find the hypotenuse, and then...
Where's the triangle going to be? Because the only triangles you're allowed to draw are these, and you got a point right here. No, you cannot draw a triangle. If you can't draw one of these, you cannot draw a triangle. Instead, we think about a circle. I'm supposed to hit that point. We think about a circle that contains that point. Now, if the circle is going to contain that point, what would the radius of that circle be? 2. So I have a circle, the radius is 2. So out 2, up 2, over 2, down 2. That's how I would get that point. I know that the x-coordinate is 0 and the y-coordinate is negative 2. That was given to me. The point, x comma y. Remember the circular definitions on your memorization sheet? And I said, well, I wasn't going to quiz you over them right now. Guess what? It's time to know those. Does anybody know the sine, cosine, and tangent definitions? What are you doing, Phil?
I need you to satisfy some field trip thing.
Okay.
And it's due by the end of today.
And you thought it was perfectly appropriate to come walking into class? This conversation's on video, by the way.
Precal stops for no one, Philip.
Sorry.
So what day is this?
It's Friday.
Okay, well, from now on, please don't interrupt. These kids paid a lot of money for this class and they want their money's worth.
Okay, I'm sorry. Thank you.
Farewell.
All right, does anybody know the sine, cosine, and tangent in terms of not the opposite over hypotenuse and all that, but the other definitions? Who memorized them? Sine is y over r. Sine is y over r. Now look, what's y? -2, and r is 2. So -2 over 2, that would be -1, which means the cosecant is 2 over -2, which is also -1. All right, anybody remember the cosine? X over r. So what's x over r? X would be 0 over 2, or 0?
Yeah.
Which means the secant, is 2 over 0, which is what? Can't sit on the egg. 2 over 0 is undefined. You can't have a 0 in the bottom.
I'll just abbreviate that.
And what's tangent? Y over x. Y over x. Beautiful. So y over x, -2 over 0, there's another undefined. But the cotan would be 0 over -2, which is 0. When do I do this? When I can't draw a triangle. And when can I not draw a triangle? When my point is on an axis. If your point is on an axis, so if your point is here or here or here or here, you're going to draw a circle. The problems the girls came up and did, their points were out here. If their point's out here somewhere, make a triangle and do SOHCAHTOA. If the point is on an axis, you gotta draw the circle and use these definitions. So let's look at the next example, 3, 0. Where is 3, 0?
Right.
Right 3, it's on an axis, which means no triangle. It means a circle. What would the radius of that circle be? 3. So I write that down. The radius is 3. What is my x and my y? They gave it to you. The point. What's the x and the y? 3 and 0. You okay? So here we go. Our sine is y over r. So what's y over r going to be? 0 over 3, which is 0. 0 on top is 0. When I flip this over and get 3 over 0, though, that's going to be undefined. So, Daisy, we got 0 on top, that's going to be 0. We got 0 on the bottom, that's going to be undefined. Everybody hear that? All right, what's my cosine? Look at your given. What's my cosine?
3 over 3.
3 over 3. So it's going to be 1.
What? I'm confused how, like, on the last one, how do we get -2 for y? Is that just, I mean, how do we get 2 for r?
the radius of the circle.
Is 2 all over.
Well, look, if the circle centered at the origin contains that point, that means it came down 2, which means its radius is 2. If the point is at 3, 0, then the radius has to be 3. And the radius will be positive, always. Alright, so x over r was 3 over 3, so the reciprocal will be 3 over 3. What about my tangent? Tangent is y over x, so 0 over 3, that's 0. But the cotangent would be 3 over 0, which is undefined. Yep.
So for the radius, you said it's one of the points, but like, what if you have, like, what if your points are 2 positive numbers and
Okay,
they're different?
then you don't do it this way, because if your point was 2, 3, let's say, then you're out here, over 2 up 3, and you're going to build a triangle.
I got you.
Okay?
I got
So the only time we worry about the circle is if when you plot your point, it's here, or here, or here, or here.
Okay.
If it's out here, then you make a triangle and do SOHCAHTOA like we've been doing.
Got you.
Alright, I know it's a long period, but I don't see it tomorrow. I gotta get through this, guys. So hang in there. We'll make it. At least we have a different kind of problem to do now. Number 3 says, tell the sign, SIGN, that means positive or negative, of the sine, cosine, and tangent in the given interval. Now, this happens a lot. It looks really hard. But it doesn't have to be. Here is my circle, or my compass, or whatever you want to call it. It's not a compass, but here's my circle. This is 0, this is 90, this is 180, and this is 270, and this one is 360. That's how we measure our angles. So 0 to 90, this is 0 to 90, this is 90 to 180, 180 to 270, and 270 to 360. Now the first question says, we want to look between pi over 2 and pi. Well, we need to change that to degrees. So how much is pi? 180. So pi over 2 is 90. So this is telling me to look between 90 and 180. So where am I looking if I'm looking between 90 and 180? Right here, top left, quadrant 2. I'm looking here. So if I drew a triangle here, any size triangle in that quadrant, this would be a negative number. Would you agree with me? Because I'm going left. What about this? Would this be negative? No, because it is going up, so it's positive. And the hypotenuse, or the radius, is always positive. X can be negative. Y can be negative. It's not in this problem. But R will always be positive. So it says you have your sine and your cosine and your tangent. You cannot possibly give me numbers because I don't know how big that triangle is. But you can tell me if it's going to be positive or negative. Sine, opposite over hypotenuse. Opposite, remember here's theta, always at the origin. Opposite over hypotenuse. Will that be positive or negative? That's going to be positive. But what about cosine? Adjacent over hypotenuse. Adjacent over hypotenuse. That's going to be negative, isn't it? And what about tangent? Opposite over adjacent. That's going to be negative. So that's all those problems want you to do, is say if it's positive or negative. Let's look at the next one. It's between pi and 3 pi over 2.
Yeah.
Alright, so where is that? What's pi?
180.
180. 3 pi over 2. Alright, so pi is 180. Half of it is 90. Times 3 is 270. So I am looking now between between 180 and 270. Look, where's 180? Where's 270? Aren't I looking down here in quadrant 3? Now, let's look at the sides of this triangle. There are no numbers, just pluses and minuses. Would this be positive or negative? Negative. Left is negative. Would this be positive or negative? Negative. Down is negative. This is always positive. So now, I don't know what the sine and cosine and tangent are, but I can tell if they're positive or negative. The sine is opposite, here's theta, always at the origin. So opposite over hypotenuse would be negative. Adjacent over hypotenuse would be negative. Opposite over adjacent. Positive, because it's negative over negative. Now, number 4 is exactly the same situation. Only instead of looking at a whole quadrant, instead of looking at the whole section, you're looking at a particular angle. Okay? Come on, we gotta get through this, and then we'll be ready for something else. We gotta get through this. So we have a sine of 152. Alright, so the first thing you're gonna do is draw 152. Now remember, this is 0, 90, 180. So won't 152 be over here in quadrant 2? Isn't 152 in between 90 and 180? So here I drew 152. Tell me about these. Are they positive or negative? Where my finger is right now, positive or negative? Negative. Positive. Positive. Now, I just want to know, is the sine of 152 positive or negative? The sine of 152, would it be positive or negative? Here's the angle you look at, always the one at the origin. It would be positive because it's opposite over adjacent, or opposite over hypotenuse. Opposite over hypotenuse. All right, 8 pi over 9, cosine. All right, what's pi again? 180. Divided by 9 would be, well, divided by 9 would be 20, and then times 8 would be 160. So now you're going to draw 160. Kids, we got to get this section done. We're going to draw 160 degrees. Where are you going to put it? Quadrant 2. How do we know it goes in quadrant 2? Because 160 is between 90 and 180. Morgan.
How do you know it's a circle?
What?
How do you know it's a circle?
You don't have to draw a circle. I just do because that reminds me it's 360 all the way around. But the circle really doesn't have anything to do with it. So if you just want to draw your triangle in quadrant 2, that's fine. The circle is just a habit I have. It just reminds me 360s all the way around. So tell me about the sides of this triangle again. What can you tell me? This side is negative. It is, somebody said adjacent. It is the adjacent side, but it's negative. This side is positive, and of course the radius is positive. I want cosine. So what can you tell me about cosine? Adjacent over hypotenuse, it will be negative. I'm going to do one more, and then I'm going to see if you can finish up the rest of them with each other. But I'll do one more. I think you're getting tired of listening to me. We want to find the tangent of 300, not the actual number, but just is it positive or negative. So the first thing I have to do is figure out where 300 would be. Remember, this is 0, 90, 180, 270, 360. So where does 300 go? Quadrant 4. So I'm going to draw my triangle in quadrant 4, and remember, every time I draw a triangle, it is a butterfly bow tie triangle. So it looks like this. Tell me about this side. Positive or negative? Positive. Tell me about this side. Negative. Tell me about this side. Positive always. Now I want tangent. So I just look here and I say, okay, tangent. Here's the angle, always at the origin. Tangent is opposite over adjacent. So that will be negative over positive, which is negative. And that's all you're doing here, is telling me if it's positive or negative. So if you put a negative over a positive, you get a negative. Okay? Now, I need you to finish this section, D, E, F, G, and H. We're going to talk about them, get them up here on the board, and then you'll be done for the day, okay? Start working with each other. If you need your calculator to change your degrees or your radians to degrees, that's fine. Some of these numbers are kind of awkward, so you might need a calculator. That's fine. A little crazy with a couple of these. Let's take a few minutes, see how far you can get. And then well, we said pi is 180.
Yeah.
So pi, I did the pi divided by 9.
Okay.
So that was 20. And then times 8.
Okay.
Now, if you have a calculator, you could do it the other way, but the number gets so big. Now, that's a weird one. So I'm going to use my calculator on that. I don't know what 180 divided by 1 is. Pi over 7. I don't think that's right. It doesn't matter, because remember, all you're trying to figure out is where it is. Yeah. Yeah. Some of these angles are funky, but remember, all you're trying to figure out is whether it's positive or negative. You do not need to worry about having any exact angle value. Is it in quadrant 1, quadrant 2? That's what you're trying to figure out.
So we don't have to do like C
You're doing cosecant 15 pi over 8, the first one you're doing. I did A, B, and C, so we're starting with C. We're starting with C.
I got positive for E.
So as far as
Negative over negative.
500 degrees, mine's better.
Oh, here's one of my trickies. I got 2 trick problems up here. This is one of them. 500 degrees. What about that, kids? It's more than
360.
once around.
Xbox.
So how much more is it than once around?
140.
140. Because all the way around is 360. And then you have 140 more. So this one's going to be drawn over here. This one's between 90 and 180 because you're really drawing 140. You're really drawing 140 degrees. The other tricky one is right here. What in the world do we do with a negative angle? Any thoughts on that? Go backwards. So instead of going this way, I'm going to go this way. Now how much would it be going backwards? How much would it be to here? Wouldn't that be negative 180? And this would be negative 270, so isn't it somewhere in between there?
217 on the check.
If I'm going to negative 200, wouldn't it be somewhere in between there?
No, we got that.
Now, once you get the triangle positioned, it doesn't matter. Nothing else matters. Just plus or minus. Positive or negative. Yep, you go backwards.
That's crazy. So you go backwards or 180 or
Go this way, go down and around. So this is negative 90, negative 180, negative 270.
Everybody uses
Now, once you look at the triangles I drew, I've not answered the question yet, but I've drawn all my triangles. Do any of those look not right? Did you end up with a triangle in a different place for any of those problems? Now, for pi over 11, you might have used your calculator, so you did the sine, or excuse me, you did 180 divided by 11. Did that turn out to be in quadrant 1, 180 divided by 11? So that's where I drew it, in quadrant 1. 180 divided by 7, but that's a negative number, so I had to go down. So 180 divided by 7 was what, 20 something? So I came down. Negative 20. All right. Are we okay where these triangles are? Let's answer the questions then. I want, cosecant. Cosecant is the reciprocal of the sine, so I need to look at opposite and hypotenuse. Opposite and hypotenuse would make this a negative answer. So how many of you said D was negative? Oh, that's not very many of you. Very good, those of you that did. All right, I want cosine. Cosine is adjacent and hypotenuse. This one is also negative. The adjacent side is negative. Remember, this is the angle you look at right there. The one in the triangle at the origin. How about here? I don't even care what it is. Everything's going to be positive, isn't it? I don't have any negatives in there, so that one's automatically positive. Cotangent. Adjacent over opposite. That's going to be negative. because it's negative over positive. And secant, reciprocal of cosine. Cosine is adjacent and hypotenuse. That's going to be positive. Now, guess what we're going to do Friday? On Friday, we're going to do problems just like this, only instead of doing just positive and negative, we're going to actually have some numbers we have to figure out. All right, that'll be exciting. You'll enjoy that.
We don't promote those type of things.
All right, so we're going to start with number 5 on Friday. On Friday, we're also going to have a little quiz, a tiny little one problem quiz. It's going to be a bird on the roof looking down at a worm on the ground. Or a seagull, one of white hats, looking down at a fish in the ocean. One word problem on Friday. Everybody got it? Okay.